So over here we will discuss some of the graphic trigonometric functions. So in this function we will have to do according to the steps. Like first of all we need to find the period, then graph the function, and then check the symmetries if we do have any symmetrics along y-axis, x-axis, or maybe it's along the origin. Okay, so let's take the first example, that is s is equal to cos 2t. So you know about the original graph of s is equal to cos t. It starts from here and ends up at this type of position. Here is our pi. The midpoint is pi by 2, and over here it's the 0. Okay, again the graph will be in this shape. The center point will be 3 pi by 2, and it ends up over here 2 pi. Okay, so this is the fundamental graph or basic graph of s is equal to cos t. So you can see over here the common period of this is pi, no 2 pi. So we have to check the period of this according to that period. Okay, so we have to take pi over the value of b, that is 2. So our period is pi by 2. So according to this period we will draw our graph. Let me just, okay, over here you can see that pi by 2 is the period. There again you can see that over here 3 pi by 2 will lie because the period is pi by 2, so the difference between these two must be of 90 degrees, or in radians pi by 2. So this will be the graph. If you want to draw it over here too on the other side of x-axis, so again over here the period will be negative pi by 2. So we are done with the graph, and the symmetries are along the origin. We can say symmetric about the origin. Okay, let's discuss the second example, that is of s is equal to tan pi by pi t. Okay, so again in tan t, if you want to draw the graph of tan t, we have to see the period. Let's say it's the original graph, and over here you can see that. Okay, let me just draw the dotted line over here. It's the pi, negative pi by 2, and over here is the positive pi by 2. So again the difference between these two is of pi. So again if you want to draw this, so again the difference must be of pi. Okay, so the difference between these two is of pi. So we can say that the period is pi. So we have to check the period according to this. Again, we need to do 3 steps: finding the period, graph, and the symmetries if we do have any. Okay, so the period will be pi, pi, pi. Okay, over here you can see the value of b is pi, so we can say that period is 1. Okay, so we have to draw the graph according to this period. Let me just erase this all. So the difference between points must be equal to 1. Okay. So if we draw 0.5 over here and 0.5, so you can see the difference will be of 1. You can, if you want to count this whole distance, that will be equal to 1. Okay, let's draw another point, and over here again have to make the distance equal to 1, and over here we still need to make the distance equal to 1. Okay, over here there will be -1, over here this will be +1. And again we need to make this distance equal to 1. Okay, over here the -1.5 will lie. Okay, so you can see that this whole distance is equal to 1, and again this whole distance will equal to 1. Let's just continue with only one of this example so you don't get confused with any other. So you just need to make this whole distance equal to 1. Okay, but over here there is a negative sign, so we have to change this whole according to this. Okay, we just need to change the direction and everything else will be the same. Okay, so this is the posture of this, and if you want to draw it over here too, you can draw. So that will be -1.5. So this will be the direction of negative tan pi t. And you can see that this gains symmetric about the origin. Alright, let's check out the third one example, that is secant pi by 2t. So again you have to see the period first of the origin graph and then take out the period according to the second function. Okay, so first of all, what we need to discuss is the original graph of secant t. Okay, that's a bit of this type. It starts from +1 and to gain starts from -1. Okay, negative pi by 2, pi by 2, pi, and okay, this will be the pi, and over here 3 pi by 2 lie. Okay, so you can see that this whole region will be equal to pi and pi, and because in secant 2 we have to complete these two shapes of both directions, so the period will be equal to 2 pi. As you know, it starts from here, from negative pi by 2, ends up over here, and then again the second direction, or you may say, then what is shape of this figure, and we have to calculate the period of both and add them together, and we get the period of this is 2 pi. So we have to go through this according to that period, and we have to find out that period, that is 2 pi over pi by 2. That is 4. Okay, so we have to draw the new figure according to this period, and we have to draw the graph and then check out the symmetries if we do have any. All right. It's really good to draw the original graph first and then check out the next. Okay, so again, the graph will be in that form. So we have to make the period equal to 2. So this distance must be equal to 2. Let's say over here is the -1, and over here is the +1. The center one will be 2, and over here is 3. Okay, so you can see that this whole distance, okay, 1, and this whole distance 1 plus 1 will be equal to that 2, and over here again 1 plus 1 will be equal to 2, and the whole period of this whole figure that's in both direction will be equal to 4. So we get the period that is equal to 4. We got the graph as well. So now over here we need to see the symmetries. So see, you can see the symmetries. Y-axis, symmetry about the y-axis, symmetric about the y-axis. I hope that you can do the last 4 example on your own, and it's quite simple. S equals to cosecant t over 2. Okay, just remember the all 3 steps that you have to do, and draw the graph of the origin cosecant t, and then move on to the next. So let's see another example. Over here we need to discuss the reciprocals of each other functions, 2 trigonometric functions, that's cosecant and secant x. Okay, and the third part is we have to draw the graph along this section, -pi/2 over to the +pi/2, or you may say that -270 degrees to +270 degrees. And we have to comment on the behavior of secant x in relation to the signs and values of cos x. Okay, so over here we will draw the original graph of cos x first, and then the secant x, and then merge these two in one graph and then discuss it according to that. Okay, so the graph of cos x is of this type. Three pi by 2. This midpoint will be of pi, and over here is the 2 pi. All right. So over here is the graph of secant x, and you know that it starts from here and goes up to the infinity and from both sides. And you know that it starts from 0 and ends up over here. It starts from 0 and ends up at -1. So we have to merge these two graphs along one of the graph. Okay, if I just merge this one over in this, and we know that, okay, you have to adjust it according to this. Okay, so we need to check out the values. So over here is the negative pi by 2, positive pi by 2. Over here is the midpoint, that is pi, 3 pi by 2. This is the midpoint 2. This is the ending point, 2 pi. Okay. And over here is the negative pi by 2. Okay, that's all right. Or you can say that it ends up over here. That is negative pi. Okay, let me just remove this whole. So you can see that how we merge this whole two graphs in one graph. And now we have to discuss these two graphs. Okay, we have to discuss this whole from negative 3 pi by 2 to the positive 3 by 2. Okay, let me just draw this. Over here is the negative pi, 3 pi by 2. Let me just use something. Okay, 3 pi by 2. Okay. As you can see that this ending point of this cos x is -1 and the starting point of secant x is -1. Okay, so you can see that the cos x and the secant x will be positive along the quadrant 1 and 4th. We get all of the positive values of cos x and secant x in first and third quadrant, in the fourth quadrant. But in second and third quadrant, we'll get the negative values of these both functions, or you may say the trigonometric functions. Because we have the negative values of x, so we get the negative values of y. That is a function, so we get the negative values in second and third quadrant. Or you already know that this figure that over here all of the positive, over here sine will be the positive one, over here the tan will be the positive, and over here the cos will be positive. So they were discussing that type of thing. Okay, so the second thing that we checked over here, when cos x is equal to 0, the secant x will be undefined. Obviously, that's the reciprocal of that, and we will get the undefined value. So we'll get the undefined value when our cos x is negative. Okay, so we learn one thing more over here, and what's that? The range of these two functions. Okay, let me just use some more space over here. Okay, the range of cos x will be from -1 to the +1. You can see that it only goes to the positive signs from the positive signs over here and the negative signs from this. So the whole range of this is from -1 to the +1. And if we want to see the range of secant x that starts from +1 but ends up at infinity from both sides. So we can write it in this way. So we learned about the ranges of secant x, cos x both. Over here is the square bracket and this is the circle bracket because the infinities go. Okay, let's discuss another example exactly like the previous one. So over here we again need to draw sin x and the cosecant x graphs, and then we'll merge it according to that. So again we have to check the whole graph from negative pi to the 2 pi positive 2 pi and the relation between these two graphs. So you know about the graph of sin x. It starts from here. It's a bit of this type. Starts from here, ends up over here. The midpoint is pi, and the midpoint of this whole semicircle is pi by 2, and over here is the positive pi by 2. Alright. And the graph of cosecant starts from here, ends up over here. And this is the positive one and the negative one of the y-axis. So again the midpoint is pi, the ending point is 2 pi, the midpoint of this semicircle is pi by 2 and the positive 3 pi by 2. So we have to merge these two graphs in one. Let's see how we do this. Let's just join these two. Okay, so over here is the 2 pi. The midpoint again will be 3 pi over 2. It's the pi by 2. And over here is the 0. Okay, we have to go to the negative pi to the positive pi. Alright, we have to extend it from this side. Over here is the negative pi. So over here is the sign, that is it's the point -1. And over here is the point that is +1. Okay, and again the midpoint of these two is negative pi by 2. So over here you can see that the values are positive in the secant and the first quadrant. The values of sine x and the cosecant x will be positive. Cosecant x will be positive in both of these quadrants. Second quadrant, let me just change the color. Second and the first quadrant, because you know that the values will be the positive, and we know that the second relation that we will discuss over here, when sine x is equal to 0, obviously the cosecant x will be the undefined, will give you the undefined value. Over here, over here, over here, over here, the values of sine x will be, it will be equal to 0, and the cosecant x will be undefined. And the third point that we learned from here is that the range of sine x and the cosecant x. Range of sine x is again from positive 1 to 0, and over here it starts from positive 1 and ends up at negative 1. So we can write it from, because that didn't go far from this. They didn't go any up from this point, the fundamental graph of sine x. But you can see there is the difference between the range of cosecant x. Let me just show it over here. Cosecant x. You can see that it starts from 1, but it goes to the infinity from this point. And you can see that it starts from negative 1, but goes to the infinity from this side, or you may say the negative infinity from this side. So we will draw this negative infinity union. Okay, let me just erase this whole. Okay, I'll use this space over here. Union positive 1 and ends up at, it doesn't end up positive infinity, you just write it. So you have checked that we will get positive values in first and second quadrant, because whatever the value that we put in x, we will always get the positive values over here, and we will get the negative values in the second and the fourth quadrant, in the third and the fourth quadrant, because whenever we put the positive and the negative values inside the values of x, we will get the negative values of y over here because of this. And the second point is, whenever our sine x is equal to 0, we will get the undefined value for the cosecant x, and we discussed the ranges of sine x and the cos x. That's it.